Good afternoon, everyone. It's a pleasure to welcome you on this ESC TV Connect session. I'm Mauro Massussi, interventional cardiologist from University Hospital of Brescia. And together with Professor Mariana Adamo and Professor Marco Metra, I contributed to the design and the coordination of the DORIAN GRAY project, an ambitious European initiative tackling one of the most pressing and under-recognized topic in the field of cardiovascular disease. That is the relationship between heart disease and dementia. I'm delighted to be joined today by Professor Dimitris Fotiadis. Professor Fotiadis is a Professor of Biomedical Engineering at University of Ioannina and brings exceptional expertise in the field of EU-funded projects, both as partner and as coordinator. Please, Professor Fotiadis, would you like to tell something about the DORIAN GRAY Consortium?
Thank you very much, Mauro. It's a great pleasure for us to be here today. I think that we managed to have DORIAN GRAY, and this is a European Union-funded project. And the title of the project is Personalized Risk Stratification and Holistic Management for Prevention of Cognitive Impairment, as you said, in patients with different cardiovascular phenotypes. The project is coordinated by the University of Brescia. Then the clinical leadership goes to the University of Liverpool from UK, and fourth from Greece, the Foundation of Research and Technology Hellas has the technical leadership and coordination. We're 24 partners. Among those, we have the European Society of Cardiology, which helps us with communication, dissemination, and other activities that are bringing us very close to the medical society, to the cardiologists, and also to the patients. I think that it will be a very successful project. We just started in January 2025, and we are partners from universities, companies, research centers, patient associations, professional associations, hospitals, and we plan to have a very successful project and very nice outcomes.
So we can say that it's a very multidisciplinary consortium. As a clinician, I would say that DORIAN GRAY is really unique because it bridges together dementia and cardiovascular research, taking neurology and cardiology together to the very next level of research. The output is to produce an advanced technological solution to better patient outcome. So for today's session, I will start with the clinical background and the clinical introduction, and then let you talk about the heart of the project, the technological heart. The relationship between heart disease and cognitive decline is well documented in literature, I guess, both the epidemiology, the shared risk factor, the pathophysiology, and even some evidence of target for treatment, yet is not still addressed in the routine clinical scenarios. That's why DORIAN GRAY is so important. MCI can affect between 12 and 80% of people over 65, and it's a middle ground stage between normal aging and dementia. And so it's a critical window for prevention, since some patients can revert to normal cognition, but every year about 5 to 10% of patients progress towards dementia. And if we think that almost 40% of dementia cases can be prevented or at least delayed by addressing lifestyle risk factor, this makes it even more important to address MCI. MCI alone is urgent, but together with cardiovascular disease is even more urgent. Heart failure affects 60 million people worldwide, with a prevalence of 15–25% in patients over 75. So in the very same population, we have together MCI and heart failure and cardiovascular disease, putting a lot of older adults, a million of older adults, at risk for dementia. There are, of course, shared risk factors like diabetes or hypertension, but cardiovascular disease itself can cause cognitive impairment. And so I think that still many gaps remain in this research field. And we would like to start in our project from the analysis of the retrospective database, which are very granular, no? With data, with neuroimaging data, biochemical data and also data from cardiovascular disease and cognitive function. And how can we merge all those data together and harmonize? I let you the stage and talk about the harmonization project.
Yeah, Mauro, you are very right about that. This is the starting point. In DORIAN GRAY, we are looking in large cohorts of data, large databases that we have from both Europe and United States, which is very important. So from that, we're looking in retrospective data and we're trying to analyze that. Having several databases around the world, dependently on how they're coming, you understand that those data are not homogeneous. Even they have coding problems or collection problems, and they are not harmonized. So the first step for us to proceed in the processing of retrospective data, in order to create the risk stratification tools, that I will speak later about those, is somehow to harmonize those data. And to harmonize those data, you have to take common parameters and use several IT tools in order to bring them in a harmonized data set. That does not mean that you are bringing all the data together, because in that case, you have to prevent problems that you might have in privacy and ownership of the data. So for us, the data will remain at the state, at the place where the data are created, or they belong, and we plan to use on that federated learning algorithms in order to access those data. What do we mean by that? Okay, federation is one thing. Of course, we have to take care about the quality of the data and other things before processing the data in the pre-processing step, and then to go and learn our AI, artificial intelligence algorithms. How we are doing that? We have the algorithms, we have the model, and we are not acquire the data. We don't collect the data in a central place. We leave the data where they belong, and then we are trying to send, let's say, sequentially to each place the algorithms and the models, and they are trained. And finally, you are getting in a central place the trained algorithms. And this is very important because you are obliged to follow privacy and other regulations that exist in different countries. And also, you protect the patients from their data and the owners of the data. So having the federated learning platform, we have a central place, which is the Prisius. The Prisius is a cloud supercomputer where we have the already trained models. And we have only the trained hyperparameters there, nothing else. So we cannot go back to the data, we cannot violate privacy restrictions, nothing about that. So having but what do we train? And this is the important. Now we're coming to the heart of DORIAN GRAY. Our platform is called Portrait. And what is that? It's the digital twin. And what we're trying to do is to build risk stratification tools. For what? Having the cardiovascular problems and the patients with that, and to see the link with dementia, with mild cognitive impairment, and so on. How do we build those algorithms? We have two directions. The first one, we call it static. So we are trying to train models using the retrospective data. And actually we are doing that because we need to have the risk stratification tools well in advance in order to test those and collect other data that we'll collect in the second part, let's say, that we'll discuss today, which is called mirror, in order to collect data from the patients and make those stratification risk decisions more personalized and actually close the loop. So we have the static risk stratification tools, plus we have the dynamic. And the dynamic, you are going also to the progression of risk and to the prediction of the progression of the risk. So for that, finally, we plan to deliver a personalized approach to mitigate the dementia risk, to promote resilience, and also to promote and improve healthy aging. This is overall the scope. But Portrait for us is a very important tool because finally the agents that we're making are not only trustworthy, and this is a property of the system, but we like to provide something which is trustable by the medical community and also by the patients. So somehow we are trying in the second part of Mirror to co-design with the patients, with the medical doctors, what we're planning to do. And what we're providing from Portrait, we're trying to provide something which is explainable, understandable, in order finally to make those models trustable to the final users. Because finally, we like to attract the people to join this initiative. Actually, predictive agents which are explainable and they are based on several techniques from AI, like probabilistic model, causal inference, and also large language models. All those will come in new stratification models, risk stratification models, which are deeply explainable and presentable and finally trustable by the research community, the medical doctors community, and also the patients.
Thank you, Dimitris, for having explained all the challenges of handling so much data and plenty amount of granular data for the first part of the research project. But now we can move to our solution, to the heart of the technological solution of Dorian Gray, called Mirror App. Why Mirror? Because it reflects back to the patient their own progress, and this is important. The app is really made up of two main components. The first is an avatar-based XR game, which is not a simple video game, but is a complex program of cognitive enhancement, putting together cognitive activities and physical exercise. And this is one of the most breakthrough innovation of the Dorian Gray, having together the cognitive and the physical rehabilitation for the patient. Typically, the activity will be delivered in a home-based scenario, so self-delivered by the patient, who will be guided by an avatar to perform the activities both cognitively and physical. The second component, even more important, is the digital coach, which not only has to encourage the adherence to the program, but more importantly has to deliver what we call the experiential learning. So to put into real life what the patient learn into the reality of the XR game, because more sustained are the changes in the lifestyle, and the most we prevent dementia. This is the core of the app. So would you like to tell us something more deep into the technological solution?
Yes, you're right. This is why we named the project Dorian Gray. We have a mirror. What does a mirror mean?
Yeah.
That you see yourself and see how you're progressing and you're trying to improve yourself when you're staying in front of a mirror. And actually, this is what we're trying to simulate. As you said correctly, we have two parts. One is the XR game, the avatar-based XR game. And the second, is the digital coaching system. Okay, so we have some modifiable risk factors that we have, let's say, to improve lifestyle. And as you said, this is based on behavioral science. It adapts on real time, on what we collect from the patient. So the patient, in order to see the avatar and have the coaching system, has a tablet. So each patient is equipped as a tablet. So imagine after the end of the project that finally we have a patient, and this is the outcome of the project, with a tablet, with the two parts, the XR game, the avatar-based XR game, and the coaching system. But how it adapts? It adapts based on physiological parameters that we collect on real time. And how these are collected by a smartwatch. A smartwatch of the market. I mean, nothing so important. So it connects and brings, adapted, in real time. The system is adapted in real time. And we're using physiological signals like heart rate, sleep quality, daily steps, activity, in order, let's say, to see what we can experience, in this interaction with the patient. Of course, this is based on the patient, is patient-centric, is co-designed with patients, is co-designed with medical doctors to interact with them from the beginning. But also, you have to understand that we have the other part, which is called portrait. And actually, portrait is fed with new data collected by the patient. It adapts to that, and actually is connected, and then it profiles the patient and provides data back to the mirror and to the coaching system. And actually, the digital twin drives this part of the system. So the portrait is the digital part of the system. The other one is what it drives and interfaces with the patient, and also it collects data. Actually, what we like finally to have. We have the two technological parts, portrait and mirror. We like to create a closed loop system. The patient interaction with the exergame generates new behavioral and physiological data. The data feeds to the digital twin, and then the digital twin models, because we have models, refine the personalized recommendation and the difficulty also of the exergame, because you mentioned at the beginning that the exergame progresses and adapts to the needs of the patients. This, again, is delivered back to the patient, and finally we have, what is called the digital intervention, because finally our system is about intervention. And actually it's not only something that will come to the patient, but we believe within the project that is a powerful research instrument in order, to create new digital biomarkers, in order to investigate new behaviors, and actually to promote the research as you began going and link, the two diseases, the cardiovascular disease and also dementia or mild cognitive impairment. So you see that finally this closed loop between the digital part, which is the portrait, and the mirror, make Dorian Gray a unique solution and a unique, let's say, project in both of innovation, clinical, technological innovation, but also human-centric, patient-centric innovation.
Thank you for having highlighted all these breakthrough innovation. I guess the continuous monitoring is crucial to have the novel digital biomarker, but also to make the response adaptive and to have a program that is different from a patient to another, adapted to their needs. So ultimately, I would say that the Mirror app should be a widely accessible tool, home-based, low-cost, and scalable to a large population of patients affected by cardiovascular disease. If we have success with the project, we also could save up a lot of money in terms of public expenses. If we think that on average in Europe, the expense for a patient at mild stage of dementia is 20,000 euros and up to 40,000 euros in the advanced stage of dementia. So our solution could be very important in this scenario.
Yeah. This is the scope. Finally, is to provide something which is scalable, cost-effective, and fully compliant with regulations. Otherwise, you fail. So in Dorian Gray, we examine all those parameters. We have, let's say, clinical excellence within the consortium in both domains, the intersection, between heart disease and also cognitive decline, and also we have excellence in technology. Merging those two directions, the clinical excellence and digital technology, finally, we plan to deliver the mirror to the patient. As you said, it should be cost-effective, something that will improve lives, will save costs from the healthcare systems, and avoid people to suffer for cognitive decline, and improve their health. Actually, this will change a lot the healthcare system and will provide, new opportunities in treating those patients using digital technologies. And also, it will provide, research-wise, a lot of new opportunities and a lot of new options. Finally, what I would like to say, we have to understand that we are looking at trustworthy AI systems, explainable AI systems, which is the portrait, which is also very important. And actually, we're not providing a black box. Black box is something that is not trustable by the medical doctors, not by the patients. No, we like to avoid that. And actually, addressing the modifiable risk factors, which is the most important thing, on a personalized approach, we can prevent up to 2 million cases of dementia by 2050. Now we are very close to submit the protocol and start the clinical study soon. And so we invite, the audience of this conference from the European Society of Cardiology, being either experts, professionals, or patients, to join us in co-designing, in co-creating, and finally providing the mirror and also the portrait application. I think that, Mauro, it's something. Thank you very much.
Thank you, Dimitris, for joining us today in Madrid, and thank you all for watching. Have a nice ESC Congress.
Thank you very much.